Hello students, here let us learn about the Andrews isotherm of carbon dioxide at 0 degree, 21 degree Celsius, 31.1 degree Celsius and 50 degree Celsius. Now isotherm, you must be familiar with the term isotherm, means at a different temperature, like this is the one of the graph, like whenever we draw a graph of the pressure versus volume, okay, so there we plotted a different graphs like Boyle's law. In the Boyle's law, there were certain graphs, isn't it? So these graphs are called as a isotherm, means this is the graph at certain temperature T1, this is the graph at certain temperature T2, this is at a certain temperature T3, but that was for the ideal gases, okay, ideal gases, and this is the graph which was plotted for the carbon dioxide gas, and this is the real graph, and this graph shows the liquefaction, okay, liquefaction of the carbon dioxide gas, okay. It also introduces where is the critical temperatures, it introduces the critical temperature over here. Let's look into this graph, means at a different temperature, this is the first line, what you can see over here, this is the first line D, C, B, A or A, B, C, D, like this is at a 0 degree Celsius. At 0 degree Celsius, like we spoke in the last lecture about the liquefaction of the gases, means if we cool the gas, then if we compress the gas, then a gas is converted to the liquid, but it is not possible for us to compress the gas at any temperature and convert it to a liquid. There is something called as a critical temperature, right? And in the critical temperature is the temperature below which the gas could be liquefied and above which gas cannot be liquefied, however high pressure you may apply. Now let's talk about something where, like this is the volume, right? This is the increase in the volume, this axis represents the increase in the pressure. So here the curve from A to B, this represents the normal pressure volume curve, right? But as soon as at the point B, means volume decreases, means this is the volume V1, let's say this is the volume V1, I am decreasing the volume, means what? I am increasing the pressure, right? That is at point B. I have increased a pressure to certain volume, and it is not that the whole gas molecule, let's say this is the gas, this is the gas container, this is the gas container, here is the gas, there are the gas particles, this is the way gas particles are there, and I am applying the pressure. As soon as it has reached to this pressure, means at certain pressure, like this also represents a pressure, at this pressure I am decreasing the volume, means I am increasing the pressure. At this pressure whole gas is not going to get converted to the liquid, okay. This is the process. Now this is the dotted area region, the region below this dotted area is the region of the two states will exist, that is gas plus liquid. Here there will be two states will be existing, that is gas and the liquid. So here the gas will start, the carbon dioxide gas will start changing into the liquid, means it is not going to convert whole of the gas into a liquid state, some of the gas will be remaining into the gaseous state, means here the gas and the liquid in this region are in equilibrium. You understand what is equilibrium? Means some of the gas particles are converting to the liquid and liquid is converting to the gas. That is what the equilibrium is. So this is the state. From here to here I am decreasing the volume. So this is the volume which I keep on decreasing. Throughout this process what remains is pressure is constant. Pressure is remaining constant. But as soon as it touches the point C, this is the point where all the gas molecules are converted to the liquid. Then this line from C to D is a liquid, means I will write this is the line, straight line from C to D is a liquid. This is liquid. This is the line it is gas plus liquid. Okay, there will be certain amount of the gas and certain amount of liquid, and this is the line which is gas. From here to here it is gas, and this is the simplest structure, graphical representation of the carbon dioxide's liquefaction. So next curve. Now we raise the temperature. We raise the temperature to 21 degrees Celsius. This is the curve of little higher temperature, 21 degrees Celsius. So from A dash to B dash, it is normal gas. It will behave as a, it will be in the gaseous state. You change the pressure, means I am decreasing the, keep this in mind, I am decreasing the volume means I am increasing the pressure. See, here at this point, this is the pressure, and at this point, this is the pressure. So there is an increase in the pressure. That is also the thing which you can keep in mind. So I am decreasing the volume. So at this stage, the gas will again start liquefying at this pressure. So here, again this is the region, and what we can observe, that gas liquefies, starts liquefying at little higher pressure. Means as the temperature increases, you require more pressure to start the liquefaction process. So from B dash to C dash, again the line is little shorter than this, that is gas in the liquid phase. So here, as soon as it touches the C dash, here is the point, all the gas molecules are converted into the liquid state, and from here C dash to D dash, it is again a liquid state. This is again a liquid state. Now, further I increase the temperature to 31.1 degrees Celsius. Now this is the point which is called as a critical point. Like, this is the temperature. Here you can see that there is no, what we can say, this region is not existing, means gas and liquid are no more in equilibrium. Gas is directly getting converted to the liquid. From here to here, this is gas. Like from here to here, this is also gas. Right? Here that equilibrium is not there. That is the critical point at 31 degrees Celsius. If you start the liquefaction of the carbon dioxide gas, it is at this point, a small point, a gas, whole of the gas is going to get converted to the liquid. Whole of the gas is going to get converted to the liquid. That is what it means. Next is, let's say 50 degrees Celsius. Now this is 50 degrees Celsius is higher than 31.1 degrees Celsius. For carbon dioxide, it is 31.1 degrees Celsius is the critical temperature. Critical temperature means below this temperature you can liquefy the gas. Means by increasing the pressure, you are increasing the pressure, the gas is going to get converted to the liquid. But for, let's say this is higher temperature, this is 50 degrees Celsius, the gas is not going to get converted to the liquid. Means gas is going to remain gas throughout. This is a curve for the gas. Like some higher temperature, the gas will be, the curves will be like this. It is not going to change it to a liquid state. However high the pressure you may apply. I'll just clean this. So, just to avoid the confusion. Right. So this is the critical point, means above this temperature. See, this point is a critical. This is critical pressure, this is critical volume, and this is the critical temperature. Above this temperature, gas cannot be liquefied. Below this temperature, a carbon dioxide gas could be liquefied. So these are the things about the liquefaction of the carbon dioxide gas and Andrews isotherm. Okay, this is the region in which gas and liquid stays in equilibrium with one another. Critical point is the point where gas is directly getting converted to the liquid. All the gas will get converted to the liquid on the increase of the pressure.